Okay, this is my model, and it's a beautiful model bounded by y equals square root x, y equals 0, and x equals 4, and then each cross-section has a width of 0.2. And the cross-sections are isosceles right triangles with the hypotenuse as the base in a semicircle, as you can see here. Perfect semicircle. And so my spreadsheet volume was square root of x over square root of 2 squared over 2 times 0.2, and my volume ended up being 1.9. And for my integral ended up having a volume of 1.166667. After I calculated the volume of negative x cubed over x plus x squared over 2 plus x, and then plugging in 1 and 0 from the integral. So basically comparing the methods, the spreadsheet overestimated my volume, and the integral gave me an exact volume, which was the better method, ultimately. And my limitations was that, like, since integrals are perfect, they're not, they can't be used for every scenario because they're too perfect. So sometimes you have to use, like, an overestimation, for example. Okay, and my problem 2, I did a baseball bat. I don't know if you can see that. Can't really see it. Yeah, so I did a baseball bat, and I found the volume, which ended up being 100.9497392, which was, there was a mistake in the spreadsheet, so it ended up being really big, but my equation was x minus 15 squared minus 1 over 100 plus 2. And as for the integral, my volume was much more accurate, and it was 21.834 after calculating 16.667 plus 4 plus 1.167, which I got from calculating the areas, and then plugging into my integral. And so comparing, the spreadsheet and integral had a very significant difference in volumes. I'm sure I made a little wrong calculation, so then it created a chain reaction, which made it like a inflated volume. And the integral evidently had the more precise volume, and I was limited by the restraints that the spreadsheet holds in regards to inputting functions, I believe. So reflection, how did completing the project paint a full picture of how calculus can be used? Allowed me to acknowledge the importance of calculus-related matters which can be utilized in real-world circumstances, like architecture, construction, and building, and all that good stuff. And I learned the implications of integrals in various situations, calculating volume. And for my comparing between the spreadsheet and calculus, I think the spreadsheet was an easier method because, like, the computer kind of does it for you, and you get to input functions and then drag it. And it's not precise or accurate since the integrals are perfect, but it's harder because you have to do more mental math, or you have to do calculations by hand. And the solutions are less straightforward because you have to do all the steps yourself. And my last reflection question, which method gave a more accurate approximation? The spreadsheet is more accurate in terms of my model since there is an overestimation, and since there's like an extra area, the spreadsheet actually works, and the integral would be too perfect for my model. Okay, and my conclusion is that I am not a robot, so my model is not perfect. It should be. And there was a big significant difference between my volumes, and I learned how to solve an integral and apply it into the context of 2 models. Thank you.